Okay, so this is assignment 6 for physics 11, and let's just do a few questions together. So if we scroll down, here's some of the extra questions, so we'll do these together. So to determine the acceleration of the system, we also want to determine the contact force between the two blocks. So whenever we have a multi-body system, first what you want to do is look at it as a whole object first. So instead of thinking of it as a separate 18 kilogram object and a 12 kilogram object, we can think of it as a 30 kilogram object, because 18 plus 12 is 30. So what we're going to first do, identify what are the forces acting on this object. So first of all, we see this applied force, that's 250 newtons, but what we need to recognize is that there's this contact force. So when this 250 newtons point to the left, this bigger block is pushing on the 12 kilogram object. But it's also because of Newton's third law, we know that there's going to be equal and opposite force in the opposite direction. So the 12 kilogram object is pushing on the 18 kilogram object. At the same time, the 18 kilogram object is pushing on the 12 kilogram object. Because it's going to be moving to the left and we have a coefficient of friction, we know there's going to be a force of friction in this direction. And there's also going to be a force of friction for the other block. I know it's already getting a little crowded. And if we call these blocks, say I call this block 1 and this block 2, I need to distinguish these different friction forces. I'm going to force of friction 1 and force of friction 2. Not going to draw, but I also know that there's up-down force as well. There's force of gravity going downwards for each block, and there's also normal force going straight up. Or normal force is the contact force, perpendicular to the surface. So when we write this out, we have F equals ma. So we always start with this equation. This is Newton's second law. F equals ma. What it comes down to is what we need to recognize is the net force acting on this is going to tell us our overall mass times acceleration of our system. So to start with, what I'm gonna say is we have F net is equal to ma. Looking at the whole system, so I'm gonna add a little t right here. So mass of our system, the total mass times the overall acceleration of the system, is equal to the sum of the forces. So now we have to see what individual forces is causing this thing to accelerate to the left. So I can say left is the positive direction. So say, okay, first of all, there's this applied force. This applied force is making it go to the left. However, it's being opposed by these two friction forces. So minus force of friction 1 and minus the force of friction 2. We can also include these contact forces, but what happens when we look at the whole system, when we write them out, because 1 is pointing one way, good, plus the contact force of the 1, but then we see there's the other contact forces in the opposite direction. So we can actually see that they are going to cancel each other out because they're equal and opposite to each other. So our overall equation becomes our mass of our system gets some acceleration, that's on the left, and the individual things that are making this thing accelerate is the 250 newtons minus our force of frictions. So I say, okay, our total mass is 18 plus 12, so we have 30.00 kilograms is being accelerated by some amount, where that's what we're trying to find. The applied force is 250.0 newtons. Then we have our force of friction. Because they have the same coefficient of friction, I could go ahead and combine them, or I can do them separately. I'll do them separately. Our force of friction is equal to the coefficient of friction multiplied by our normal force. But when I'm looking at our object here, because it's a flat surface, we know our normal force is equal to the force of gravity. Okay, so we end up with force of friction is equal to mu Fg, the force of gravity. Okay, those are our individual equations. So when we write it out, we have 250 newtons minus the coefficient of friction multiplied by force of gravity is mass times gravity. So if I look at this 12 kilogram object, so this is right in that coefficient actually. So our coefficient is 0.250, and our first object is 12.00 kilograms multiplied by gravity, 9.81. We're also subtracting the other object, which is 18 kilograms times gravity. So now we have Pretty long equation, but there's only one unknown. That acceleration, this is what we're trying to solve for right here. Our acceleration. Just plug this in, we have 250. And we're going to subtract 0.25 multiplied by 12 multiplied by 9.81. Then we're going to subtract 0.25 multiplied by 18 multiplied by 9.81. So we end up with 30.00 kilograms times our acceleration is equal to a net force of 176.425 newtons. Now we can just divide both sides by 30 and we get an acceleration of this object of 5.88 meters per second squared. So 5.88 meters per second squared. So that's the first part. Now we have to find out what is the contact force between these two blocks. So I'm going to clear this. I'm going to write down my acceleration, which is 5.88 meters per second squared. If we want to find the contact force, now what we're going to do is we're going to look at one of these two blocks. Doesn't matter which one, you just choose one, you go with it. It's going to be easier to look at this 18 kilogram block, because if we look at each of these blocks separately, the 18 kilogram block has that contact force pushing it to the left, but it also has that force of friction opposing it. Okay, force of friction caused by the 18 kilograms. If we look at the other block, the 12 kilogram block, we have the 250 Newton force, the applied force. It's being opposed by that contact force from the 18 kilograms, and there's that force of friction. So we can choose. It doesn't matter which one we look at. The first one, this 18 kilogram block, only has two forces acting on it in the direction of acceleration. The other one has three forces. Again, there's still that force of gravity. There's still that normal force. Yeah, this is block 1 and this is block 2. Add some 1s to these. Right, there's still that force of gravity. Still that normal force for each of them. But again, we're only really interested in the direction of acceleration. And we only need that normal force of gravity for determining friction. So let's look at the 18 kilogram block. Say, okay, start with F equals ma. But now we're only looking at the 18 kilogram block. The 12 kilogram block doesn't exist right now. All we know is that 12 kilogram block is creating this contact force right here. So we have mass of object 2, the 18 kilograms, times the acceleration. We just found that. This block is accelerating at 5.88 meters per second squared. And the contact force is making it move left, accelerate left, and it's being opposed by that friction force. So now I just fill in my numbers. I have 18.00 kilograms multiplied by 5.88. If you can, keep more decimal points for your acceleration when you plug this value in. So if it's in your calculator, hold on to that. We have FC minus our coefficient still 0.25. The mass is 18 kilograms. And gravity is pulling it downwards. That's our force of friction if you forgot the equation. When it's on a flat level surface. So to solve for FC, we're just going to add the 18 times 5.88. And because there's that subtraction there, it's going to become positive when we move it over, plus 0.25 multiplied by 18 multiplied by 9.81. So we get a contact force of 150 newtons. A good way of checking your work in these ones, if you solve for the other one as well and you get 150 newtons, you know you did it correctly. So because of Newton's third law, we know that two contact forces must be equal and opposite. So it doesn't matter which one you do, you should get 150 newtons.